Hi guys, welcome back to the vlogs.
Hi guys, welcome back to the vlog.
12.4 addition and subtraction rules. We're going to talk about all this symbolization and stuff and what we're going to do. Addition and subtraction rules. Okay. In probability. Okay. In probability, it should say the word or means at least one of a set of events occurs. So, when you have probability and they use the word or, it means at least one, which means I can have more than one thing or only that one thing, okay? When I show probability this way, it says probability of A or B happening, okay? The probability of A or B. To find that, you do the probability of A, you add it to the probability of B, and you subtract from it the probability of A and B happening together, okay? Because it overlaps. Because what happens is, basically, and I'm going to show you this in a picture in a minute, but if I have this and this, okay, and this is the probability, and this is A, and this is B, this is A and B happening, yes? So if I'm looking for or, I can't include this overlap in it because I would be counting it twice. Does that make sense? So what I'm doing is finding the probability of this happening, adding it to the probability of all of this happening, and subtracting the common ground from it. Okay? This is also known as a union of A and B. And you can see it written like this, right here, where it says P, the probability of A. This symbol stands for union, hence the U shape. Okay? Union of B. The probability of A, the union of B. It's the same as saying the probability of A or B. You can see it written either way. Here's your problem with this lesson. If you don't know what these symbols mean, you're not going to answer anything right. Okay? So or and union are the same thing. Does that make sense? They'll use them interchangeably too. They're going to switch it up on you. Because if it's written in a word problem, it's going to probably say or. But if they show you with just symbols, it's going to be the union symbol. Okay? So if you don't know symbols, you're not going to do well. Okay, so then we get a couple of types of word problems. The first one says, what is the probability that you roll a 6 on at least one of 2 dice? Okay, what's the probability you roll a 6 on at least one of 2 dice? How do you think I need to set that up? How do you think I need to set that up? What's the probability of rolling a 6 on at least one of 2 dice? So, how many dice do I have? 2. And how many possible 6s do I have?
2.
Okay, but let's keep each dice individually. On one dice, what's the probability of rolling a 6?
1 out of 6.
So, 1 out of 6. So if it's at least one of 2 dice, that means the probability is 1 out of 6, yes?
Yes.
Now, you said that we have 2 dice, right? And there's 1 out of 6 on this one, and there's 1 out of 6 on this one, yes? Okay, so I am trying to figure out the probability of A or B happening, okay? Because it's at least 1, which means or union, okay? So, if I figure out the probability of A plus the probability of B and subtract from it the probability of A and B happening, I can figure out what's going on. So, the probability of dice A would be 1/6, right? The probability of dice B is also what?
1/6.
And the formula tells me that the probability of A or B, right, equals the probability of A plus the probability of B minus the probability of both
A and B.
A and B. What's the probability of A?
1/6.
What's the probability of B?
1/6.
What is the probability of A and B? No, 1 over 36. Because you would do 1/6 times 1/6, right?
Yeah, you just multiply straight
And you
across.
get 1/36. Now, to add and subtract these fractions, what do I need? What do you have to add or subtract fractions?
Common denominator.
Common denominators. So I just need to change these. How do I change these to 36 on the bottom? You multiply by what? No.
What was the question?
What do I multiply these by to change them to 36 on the bottom?
6.
6 over 6, yeah, 6 over 6. So if I multiply this by 6 over 6, I get 636, I get 636, and I'm subtracting 136. What is 636 plus 636 minus 136? 11 over 36. So now I have found the probability of A or B taking place. Does that make sense? Okay. Now, of 100 students surveyed, 95 like chocolates or raisins, 35 like both chocolates and raisins, and 40 like raisins. How many students like chocolate? Okay. I can also do this visually for you, like we can draw a, like we could draw this and kind of break it up so that you can see, okay? And we can name one box chocolate, and we can name one circle chocolate, and we can name one raisins. Does this make sense a little bit? Another way of looking at it. The total probability is out of 100 people, okay? How many 95 like chocolates or raisins, yes? Okay, so 95 equal chocolate or raisins. Okay, 35 like both, which means this segment here would be 35. Does that make sense? Because it overlaps. And 40 like raisins, right? Okay. How many students like chocolate? So we know that 40 like raisins. This whole part is 40, which means it wants to know how many students like chocolate. How can I work that backwards to figure it out? If my problem is usually the probability of A or B equals the probability of A, right? Plus the probability of B minus the probability of A and B, correct? Okay. If I have that formula, I can plug things in and kind of just, I don't even need to do all this work. I just need to do a couple little things.
Can you just add 40 and
plus
35?
minus 100?
No, minus
100
90.
minus
Minus 95?
Well, it's out of 100 students.
It is out of 100 students.
So couldn't,
Listen, I know what you're saying. You're thinking kind of correctly. We just got to tweak it a little bit.
because it's minus 95 like it.
How many
So
like
minus 95.
chocolate or raisins together?
35.
No, chocolate
No.
or raisins is
Chocolate
95.
or raisins.
Chocolate or raisins is 95, which would be, if I change that to a percentage, would be 95 out of 100, correct?
Yeah.
Like both, which is what percent? Well, what
95.
decimal? 0.95, right?
95.
Okay, this is this right here, correct? They gave us the answer, like last time we were trying to figure out A or B. They gave us A or B. Does that make sense? Okay, so they gave us the 0.95. So I can plug that in to my equation to say 0.95 equals. Okay, now I'm trying to figure out everything else. I don't know the probability of A because A represents chocolate, so I know that's what I'm trying to find. That's not going to leave. Do you know the probability of raisins, though?
40.
40 out of how many?
100.
So then what would that be decimal-wise?
40.
0.4. Minus, right, the probability of A and B, okay? The probability of chocolate and raisins, okay? What is the probability of chocolate and raisins?
0.4.
Point what?
35.
3.5, because there are 35
Uh,
total that like both. So 0.35. Do you see how I can work this backwards now?
yeah.
Okay? So, how would I solve this, or what would you do from there?
100 minus 0.4 from 0.35.
Okay, you want to add 0.4 to negative 0.35?
Yes.
Okay, so you have 0.95 equals the probability of A plus 0.5, right?
Mhm.
Now 0.05?
That's not bad.
0.05.
Yeah, 0.05.
And then minus that from 0.95.
0.05, and then subtract it from the 0.95?
Yes.
So then what would your probability of people that like chocolate come out to be?
90.
90. So how many chocolate likers are there?
90.
90 people.
Oh, shoot.
Do you see how we work that problem backwards?
Yeah.
Okay? So, my suggestion is this. Always write this out up top, and then go back to the wording in the problem. 95 like chocolate or raisins. Or, that's where that goes. Okay? 35 like both chocolate and raisins. And, that's where that goes. Okay? 40 like raisins. That's where that goes. Then I have my blank. Does that make sense? If you write out the equation first and then look at the wordage, you can match it up. Okay? If you just try to like do this from the beginning, verbiage, I guess is what I should say. Verbiage. Yeah. Verbiage. Okay. Okay. So then there are events that are called mutually exclusive events. Okay? Mutually exclusive, it means it is impossible for both events to occur. Not possible for both things to happen at the same time. It's impossible for both events to occur. If events are mutually exclusive, the addition rule can be simplified. So, the probability of A, and this stands for not B, instead of union of B, not B equals 0. Okay? Meaning, when I put those two things together, it's not possible to happen. It equals 0. The likelihood of it happening is nada. Okay? Mutually exclusive events look like this. Okay, the P, A, or B. Do you see how there is no overlap in this diagram? Okay? So when they're mutually exclusive, they're separate from each other, meaning it's either the probability of A or B happening. So I take the probability of A happening plus the probability of B happening, and what should it add to B? What percent? 100. Because they are exclusive from each other, it should add to be 100. Okay? Non-mutually exclusive has this overlap area, okay? And that's where this comes into play, what we were just working on. So when they're not exclusive, they have an overlap, okay? And that's why these would add up to be more than 100, so you have to take away the middle section from them. That's what we're doing. Okay, so then it says, what is the probability of a 3 or a 5 on a single die? What is the probability of a 3 or a 5 on a single die? What's the probability of one of those? How do I figure that out?
It's just an
Wouldn't
equation.
it be 1, and the probability 1/6, or 1/6, with the probability of 1/6 plus 1/6?
Almost.
Darn.
Okay, so it is the probability of A or B happening, right? And the probability of A is 1/6. You are correct. Plus the probability of B, which would also be 1/6, because rolling a 5 or rolling a 3 is a 1 out of 6 chance. Rolling a 5 is a 1 out of 6 chance. What's the probability if I'm rolling one die that both of those happen?
0.
So it's minus
Oh.
0, the probability of A and B. Okay, so it's minus 0 in this case. So then my chances come out to be 2/6, which equals what?
1/3.
1/3. Okay, so the probability of A or B happening is a third of a chance. So I can roll a 3 or a 5 on a dice. I have a 33.3% chance of rolling a 3 or 5 anytime I roll a dice. Does that make sense? Okay, I can't have both happen at the same time because I only have one die. You really have to put on thinking caps and think through wordage. Verbiage. Is really I keep saying wordage. It's okay, I'll make up my own vocabulary, how's that? Okay, so when we are talking about, this is actually probably the easiest thing. Not A is the complement of A. What does complement mean?
Add on to it.
Like, yeah, they kind of go together, right? Okay? It consists of all outcomes that are not the event. So if I'm trying to find the probability of not A, that means if I know the probability of A, I subtract it from what? to find the probability of it not happening.
0,
No.
Okay.
100, 0.
But from 1 or from 100%. So if I say, hey, the probability of Kayla getting an A is a 42% chance.
Wait.
Okay, 42% chance.
Wow.
What's the probability of Kayla not getting an A? You would do 100 minus 42.
That's a
Dang.
big mega.
Okay?
Ooh.
Does that make sense? So it's like literally common sense. You take whatever it is and you subtract it from 1 or you subtract it from 100 if it's in percent form. Okay? Literally the easiest thing. So, it says the probability that Charlie catches a fish tomorrow is 0.3. The probability that Charlie doesn't catch a fish is what? So I would say probability not catching, okay? And you still have to show me the work. 1 minus 0.3 equals 0.7. So you have a what percent chance of not catching a fish?
70.
70. If I want to change it, I would change it to 70%. Okay? But for now, I'm just going to leave it at 0.7 because it didn't say what percentage. The probability that toast lands butter side down is 0.85. What's the probability that it lands butter side up? Probability of not down
You didn't even make it dead.
equals 1 minus 0.85, so you get what?
0.15.
0.15?
Yeah, 60.
Okay? That is what you are literally doing on those.
She takes mine.
That should be easy peasy lemon.
I was practicing.
Yeah. Just not,
For
oh,
what?
that's the end. Okay? That is what you are working on tonight for probability in lesson 12.4. What?
Can you go back one slide? The definition.
Like, subscribe, comment, tweet me at David Dibberg. Anything else to add? Korea
Kayla?
or faith?
Anything else to add, Kayla?
I don't
Just
know
wanna
anything there.
die.
Bye guys.
Hey.